Here we'll discuss how to convert hexadecimal number to binary numbers. So let me just take an example and then tell the process. Let's say there is a hexadecimal number which is 1A with base 16 and I have to convert that to a number which is base 2 or that is a binary number. So what is the general process? So there are two processes. I'll say to the two of the process. One is shortcut one is a general process. So the first process is the hexadecimal number. First, it has to be converted to a equivalent decimal number with base 10, and then that has to be converted to the equivalent binary number. So like this it can be done, or there is a direct way also, we'll say that later. So first is how to convert that to decimal number. So how to convert that? As you know, we have to multiply the place value with the hexadecimal number. So that means 1 into its place value is 16 to the power 1. So base is 16 here, so we multiply 16 here. Then plus a into 16 to the power 0. So here the for a the place value is 0. So that is equals to, so 16 power is 16 and 1, so it is 16 plus a value is what? 10. In hexadecimal number 10 is represented as a, so we write 10 into 16 power 0 is 1, so that is equals to 26. Now here I will write 26. So this is my decimal equivalent of the number. Okay, next the 26 has to be converted to binary number. So how to do that? So for 26 what we'll do is we have to divide with 2 consecutively. So I'll write 2, so here I'll get 13 and the remainder will be 0. So how to convert this decimal to binary, you can check in my previous videos I have given there. Then again 2, so here I'll take 6, 12, so remainder is 1. So you have to take again 2, here I'll take 3, the remainder is 0, and then finally it will be 2 into 1 and the remainder will be 1. So what is the binary equivalent? We have to write in this direction. So it is 1 1 0 1 0. So this is the binary equivalent of this hexadecimal number. So this is the general process. So let us do the normal process, means shortcut process. What is that? So in shortcut process, what we have to do, I'll take the same number so that we can verify also. So this one has to be represented with equivalent values of, let's say this is base 16 and this is base 16. So this combination will get as the binary number. So what I have to do? So this one individual numbers has to be represented in its equivalent binary number. So what is the, so 10, sorry, 10. So what is the binary equivalent of 1? Binary equivalent of 1 in decimal is, we know, if you take 1 in the decimal, then the binary equivalent is also 1. Okay, but in hexadecimal number you have to represent this as a 4-digit number. So how I represent? So if I write 0 0 1, so then this is the binary equivalent of 1 in uh, uh, if I want to represent in the hexadecimal number. So here I'll write 0 0 0 1 with base 2. Again, what is the binary equivalent of a? So a means what? A means 10. So if I write the binary equivalent of 10 in decimal, 10 and binary equivalent at, so it will be what? It will be 1 0 1 0. Okay, so this is the binary equivalent of 10. So here in place of a I'll write 1 0 1 0 with base 2. Okay, then this is the total binary number. So what you have to do, you have to combine these two and write it as a one number. We'll write 0 0 0 1 1 0 1 0. So this is my final binary number. So now you can check here. So what is that? 1 1 0 1 0. So here I am getting 000 and then 1 1 0 1 0. So this part you see is same in the both the cases. Whatever zeros are there in the left side, that doesn't add any value to the number. So this is how directly you can convert. So this is the easiest process actually. If you get confused, then you can go with the normal process. So let us take another example of 3 digits. Okay. So if I let's say I take 2 a 6 in base 16, what is its value in the binary? So we'll follow this process. So how to do that? So first I have to write what is the binary equivalent of 2 in 4-digit binary. So 2 can be written as 0010. So this is binary equivalent of 2. Then F. F means what? F means 15. So 15 is equals to 111141. Okay. And how I am remembering this, I will tell you that also later. Then 6. So 6, how it is written? 6 is 0110. Okay. Now what is the binary number? How we can write? So it is 2, that means 0010. Then F, that is 1111. Then that is 6, so 0110. So this is the binary equivalent of the number 2f6. So you can write directly like this. So this process is actually the easier process, and if you follow this process, it is less confusing as well, and you can get the correct answer, but it becomes lengthier. So the same thing you can do in the previous process also. So how to do that? So 2f6, I have to convert that first to decimal number. So to convert that to decimal number, what I can do, I'm just comparing this to the other method. So here place value is 0, 1, 2. So here it will be 2 into 16 power 2 plus f into 16 power 1 plus 6 into 16 power 0. Okay, then you can, we have to calculate all this value, you get a decimal number, and then we have to, what you have to do, whatever you got, you have to divide that with 2 consecutively, you will get the binary number. Again with hexadecimal, the calculation becomes complex. If 4 digit is there, then here 16 power 3 will come. Okay, so it becomes difficult. So that's why generally conversion from hexadecimal to binary, this process is used. This is the easiest process. Now, how do you remember all the binary equivalent values of the number in hexadecimal? So what are the numbers? So in digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, then 9, A, B, C, D, E, and F. These are the numbers. So binary equivalent of this hexadecimal number is 0000. For 1 it is 0001. For 2 it is 0010. So you know that every time you just change from 0 to 1. Then I change 01 was there, then I made it to 10. Then I'll make 0011. Okay, so this pattern will be followed. First 0000110, then 11. Again it will start here 0100, 0101. For 6 it will be 0110. For 7 it is 0111. Then for 8 it is 1000. For 9 it is 1001. For A it will be 1010. For B it is 1011. For C it will be 1100. For D it will be uh, 1101. For it will be 1110, and for F it will be 1111. So if you want, you can convert that to decimal. You can rectify also, means check also, cross check also. So by practice, easily you can get remember all those things. It is not very difficult. If you remember this, then this conversion will be very easy for you. Okay. So in next video, we'll do some other type of conversions.